All right, here we go, folks. We're going to go ahead and do this review a little bit differently, so hopefully this all works for everybody. Number one says solve the system of equations below using an augmented matrix and reducing to row echelon form or Gaussian elimination. So the matrix that you should come up with to represent that system of equations should be 1, 0, 3, and then 10, and then -1, 1, 4, 7, 0, -1, -2, -2. Okay? So this is, you set this up. This is the augmented matrix. Remember, this is the augmented matrix right here. And then to do reducing a row echelon form, reduced row echelon form, we're going to get ones on the diagonals. We're going to get ones on the diagonals and zeros below. And then we'll use either back substitution or Gaussian elimination to make this work. So here we go. Here we go. Hope you're ready to roll. So it looks like we already got the 1 here. I want a 0 right here. I want that to be a 0. So if I add row 1, so this is row 1, this is row 2, and this is row 3. So if I add row 1 plus row 2 and replace it with row 2, I get 1, 0, 3, 10 on the top. Then I get 1 plus -1, which is 0. 0 plus 1, which is 1. 3 plus 4, which is 7. 10 plus 7, which is 17. And now, we got to this. The bottom row didn't change either. And now what I want to do is I want to eliminate that -1 there to make it a 0. This is the Gaussian method right here, okay? So I want this to be, so I'm going to change colors here. So I want to get rid of this guy right here. So if I added row 2 and row 3, so if I take row 2 plus row 3 and replace that with row 3, that will give me what I want. So top one stays the same. 0, 1, 7, 17. The second one stays the same. Now I take row 2 plus row 3. 0 plus 0 is 0. 1 plus -1 is 0. 7 plus -2 is 5. 17 plus -2 is 15. I'm now really close because I want this now to be a 1. So if I divided by 1 or divided by 5 or multiplied by 1/5, so if I take 1/5 times row 3 and replace it with row 3, it'll give me exactly what I want. 1, 0, 3, 10, 0, 1, 7, 17, 0, 0, 1, 3. So now I know that z equals 3. Okay, so z equals 3. If z equals 3, we could say that 1y plus 7 z's, which z is 3, so 7 times 3, has to equal 17. We could then subtract 21. 17 minus 21, we get 1y equals -4. So now I know z and y. I can come up and I say, well, 1x plus 0 y's plus 3 z's, which is 3 times 3, has to equal 10. Now notice there's no, right here, so there's 0 y's. So I subtract 9. I get x equals 1. So there's my solution. My solution is 1, -4, and 3. And I'm done. Okay? All right. Let's go ahead, get to a new page now. And here we go. Number 2. So number 2 says, number 2 is big. It has all these operations that they want us to do. No problems. Number 2 says, we want to first take, so 2a says we want to take 2a plus 3b. Well, so 2 times a. A is a 2 by 2. 2, 4, -1, 3. So multiplying that by 2 is going to give us 4, 8, -2, 6. Plus 3 times b. B is also a 2 by 2, which is a good thing. Because the only way to add these two together or subtract them together is if they're exact same dimensions. So I get 18, negative 6, 9, negative 12. I'm multiplying those all by 3. Now I add these together, and the resulting matrix that I get out is 22, 2, positive 7, positive 7, and negative 6. And there's your answer. Okay, let's look at B. So B says we want to find B times C. Okay, well, B is a 2 by 2. 6, negative 2, 3, negative 4. C is also a 2 by 2. Ah, sugar booger. I don't know if you guys are even hearing. I'm going to finish this up, and then we'll see if this has got sound or not, because I keep forgetting. C is also a 2 by 2, 0, 5, 3, 6. So now I want to multiply these together. So this is a 2 by 2. This is a 2 by 2. The two inside ones are the same, so that means we can multiply them together. The outside one is your new dimension. So our new matrix is going to be also a 2 by 2. So this is going to be a 2 by 2, which means we're going to have 2 rows and 2 columns. So to find row 1, column 1, I take row 1. Let's get a different color here. We're going to take row 1 times column 1, and I take 6 times 0. So 6 times 0 plus, cross to the left, down with the right. So negative 2 times 3. So that's going to equal negative 6. So row 1, column 1 is negative 6. To find row 1, column 2, I take row 1 times column 2. Start with 6 and the 5. So 6 times 5 plus negative 2 times 6. 6 times 5 is 30. Negative 2 times 6 is negative 12. 30 plus negative 12 is 18. So row 1, column 2 is 18. Now to find row 2, column 1, I'm going to take row 2 times column 1. So I get 3 times 0, which is 0, plus negative 4 times 3, which is negative 12. That's going to be a negative 12. Then to find row 2, column 2, I take row 2, which is starting at the 3, multiply it to column 2. 3 times 5 is 15, plus, across left, negative 4, down with the right, times 6, negative 24. 15 plus negative 24 is negative 9. Okay, so there is that one. All right, let's finish this. Let's just finish this problem. We got C, and that's it. So let's do C. C says a squared. So what does that mean? Well, C, when it says a squared, just really means that's the same thing as a times a. So I take a, which in this case is 2, 4, negative 1, 3. I'm going to multiply it by 2, 4, negative 1, 3. So again, this is a 2 by 2. This is a 2 by 2. So we're going to end up with a 2 by 2. And we can multiply them. So I take row 1 times column 1. Okay? So row 1 times column 1. Here we go. Start with 2 times 2 is 4, plus 4 times negative 1, negative 4. So row 1, column 1 is going to equal 0. Now to find row 1, column 2, I take row 1 times column 2. So start with 2 times 4, that's 8. Cross the left, down with the right. 4 times 3 is 12. 8 plus 12 is 20. Now to find row 2, column 1, I go to row 2, column 1. Negative 1 times 2 is negative 2. 3, cross the left, down with the right, times negative 1. Negative 3, that's negative 5. And then to find our last one, row 2, column 2, we take row 2, negative 2, times 4, negative 8. Cross the left, down with the right, 3 times 3 is 9, and that's a 1. So there's the answer. Christmas colors. Yeah, Merry Christmas. All right, we're going to stop there. And we'll do the next ones in a minute.